Sure, man. Yes, sir.
Yes, sir. Am I audible, sir?
Hello, Shivaraman.
Yes, sir. Am I audible, sir?
Shivaraman, am I audible to you?
Sir, you are audible, sir. Am I audible to you, sir? Hello, sir. Am I audible, sir?
Hello, Shivaraman.
Yes, sir.
Hi, good evening.
Good evening, sir.
So I was not audible to you with that lead, right? Earphone. I am audible now,
Yes,
right?
sir. Wait, you were audible, sir, but what I am saying was not audible for you, sir, previously.
Previously, what? Sorry, previously.
I think so. My voice was not audible to you, sir.
Okay. Oh, maybe. Okay. Let other people join. They are joining. We will start the class at 6:05. Shall we start the class now? So I'm Sunny Kumar Sharma. I'm research scholar, PMRF research scholar in IIT Kharagpur. Uh, in this session, I will be summarizing week two session of the traction engineering course of NPTEL by Professor Hibzur Rahman. Last week, I summarized week one, and uh, I will give a brief summary of that week first. Then I will be giving some question answers with I will also summarize lecture 6, 7, 8, and 9, and then tutorial also. So this will help you in solving the weekly assignments which you people are doing. So let me give a brief of that in one two slide, the brief of that first week. Last week, I gave uh, you people are there, right?
Yes, sir.
So in last week, uh, I gave an introduction about what traction is, and to traction is if a tire is there, when it engages with the soil surface, some shearing action takes place here. With that shearing develops thrust, which we denote with F, and and it also gets some initial resistance, which we denote with rolling resistance RR. Uh, as the torque is applied, this phenomenon happens, and a ground reaction is also developed in the soil. Suppose some weight is coming here. So the this thrust minus rolling resistance is nothing but pull. When there is no pull, this thrust is balancing the rolling resistance, and when the pull is applied, this thrust minus rolling resistance is pull. The pull which we generate is the main thing in traction, which we discussed also in the last week. In the last week, the important thing which we discussed is uh, the tire terminology. Suppose this is our tire. This height, this diameter, which is designated on the tire, is called nominal rim diameter. It is not included with the rim diameter. Rim diameter has a diameter which is greater than, somewhat greater. Actually, this flange height, if we add if nominal diameter in nominal rim diameter, if we add this flange height, we get this rim diameter, and this height is called section height. This section height is also not designated. Actually, section width, this width is designated on the tire. For finding the section height, aspect ratio is sometimes given on the tire, which is nothing but height is to width ratio. This is section, this is aspect ratio. So from here we can calculate our section height, as section height is equal to aspect ratio into section width. So in problems, generally in gate problem, or in assignment, or to find the overall diameter is the main thing you need to do. So overall diameter is, we have nominal rim diameter given in our question. This suppose this we do it with R. This R you have to multiply with 1.067, so that you will get this rim diameter. This we got rim diameter, and 2 into section height you have to do, but section height is not given. For that you have to do 2 into aspect ratio into section width, which is given on the tire. This is basic fundamental which you always have to apply for to find the overall overall diameter of any tire. Next thing which we discussed was tractive performance parameters. There are mainly 5 tractive performance parameters, uh, which we learned last week. Travel reduction ratio is also sometimes designated as slip, which is nothing but 1 minus v actual by v theoretical, which you people also can derive. This is distance traveled in no load condition minus distance traveled in load condition by distance traveled in no load condition. So distance traveled is nothing but 2 pi into theoretical velocity by omega minus 2 pi actual velocity by omega by 2 pi. This distance with no load is theoretical velocity by omega. So 2 pi all cancelled. Omega you have to keep same. This is also called, to keep that omega same, we do this performance in no load condition, zero slip condition. From here we get Vt minus Va by Vt, which is 1 minus Va by Vt. This is slip formula. Next, tractive performance parameter which we discussed last week is net traction ratio, which is pull by dynamic weight coming on the wheel. Tractive efficiency is drawbar power by axle power. Gross traction ratio. Gross traction ratio is total thrust coming on the wheel by dynamic weight coming on the wheel. Motion resistance ratio is RR. Motion resistance is RR and motion resistance ratio is RR by W. So this was all about last week. Now we will move to this week's lecture. So I will be starting with problem only. So I think how many students are here? So Sivaraman, only you are there. So you tell me, in case of a towed wheel, which of the following expression is valid? If you have seen the lecture of Ramansar, then you will be able to answer
Yes,
this
yes, yes.
question.
Um,
Option B, sir. TF is equals to R in it, sir.
Which TF is equal to RNH? How? Can you elaborate?
Because TF is the thrust force we are gonna give through the torque, sir. Then uh, uh, then the horizontal force of the soil reaction will be the R in it, sir. So when we give the TF opposing it, we can give the motion, sir.
Yes, you
So
are
the
absolutely.
TF will
Yes,
be
yes,
equals
you
to
are correct.
RNH.
So let me explain this. Uh, what you said is correct. This is the in case of towed wheel. If we have a towed wheel, what we are getting, we have some vertical weight coming. This is the towed force. This is the radial force coming on the tire which passes through the wheel's center line, uh, and this is denoted by Rn. This radial force, if we break in two component Rnh and Rnp, then this Rn will V will take care of this W. This will balance the W, and this Rnh will balance the towed force. So the correct answer is towed force is equal to horizontal, this horizontal component of Rn. Yes, you are correct. So answer is D. Coming to the next question. So the weight coming on a wheel of radius 1.3 meter is 400 kg. Suppose this is the wheel. The weight coming on it is 400 kg. Its radius is 1.3 meter. The offset of the point of the soil reaction from the wheel's vertical center line means the reaction which the tire is, which from the soil which exerts, and the wheel's center line, this offset is 5 centimeter. So you have to calculate the force required to tow the wheel. Means tow force you have to calculate. What will be the force required? Can you do this problem?
let me try
Right,
it.
sir.
How will you proceed? We have the formula with us as offset amount is equal to towed force by W into radius. Everything is given in
Yes,
this
sir.
expression. You have to calculate the towed
Yes,
force.
sir.
Do this calculation.
15. Getting answer like 15.38, sir.
15.8 or 15.3?
15.38, sir.
38. 15.38. Okay. This will be 38 and you are correct. This is 15.38. It was very simple. So coming to the next question. In case of self-propelled wheel, last time we did it with road wheel and this time we have self-propelled wheel. You have to tell that which of the following expression is correct. In self-propelled wheel, the pull is 0. We have some torque which is denoted by T. Weight coming on it is W. The radial soil reaction is denoted by Rn. The thrust developed by tire and its reaction is denoted by RT. If we break its component, this is horizontal component of thrust, this is vertical component, and in Rn, this is horizontal component, this is vertical component. So you have to tell which of the following expression is correct. If we make it in more clear way, this is RT, this is Rn.
Option D, sir.
Okay. This is RNH. This is RTV. What you said D, right? This is RTV and this is RNV. So this RTV and this RNV will take care of the weight coming on it, and this RTV and this RNH will be opposite each other, and this is nothing but zero slip condition. So you have to find where RTH RTV. So you can cancel out this RTH RN. W is RTV plus RNH. You can see from here. W is RTH plus RNH. You have option B or option D, and RTH is equal to RNH. So this is also cancelled. This is minus. This is also cancelled. Yes, you are correct. So the answer is D. Moving to the next question. Next question is in case of driving wheel. Tell me which of the following is correct. In driving wheel, we have pull also and torque also.
Pull and torque also, sir.
We have torque. This is pull. This is weight coming on it. And in the same way, this is radial swell reaction. This is tangential reaction. This is radial. This is tangential. Do this. This is Rn. Radial tangential will be somewhat of higher magnitude. That is the only twist here. This is tangential component. It has some higher magnitude. What answer you got?
So 1 minute, sir. Is it option A, sir?
So this is the basic fundamental of this driving wheel. So weight is RTH, weight is RTV plus RNH. That will be always there. Weight is RTV plus RNB. Weight is RTV plus RNB. This is cancelled. RTV plus RNB. We have three options. And for pull, this extra magnitude will develop pull. So this pull is nothing but RTH minus RNH. Pull is RTH minus
RTH minus RNH.
this RNH. RTH is not
Yes,
RNH.
sir. Yes, option A correct, sir.
Option A means RNH will have
Yes,
some R.
I given that RNH minus RTH, sir, instead of RTH minus RNH.
That is for means in other expression we have plus. So pull is the difference of this one of the higher magnitude and one of lesser magnitude. That is correct. Means the correct answer is A. Okay. Then coming to next slide. Here I have shown three graphs. You have to tell all the graph is with respect to wheel slip, wheel slip, wheel slip. You have to tell that on y-axis in graph A, what is on y-axis, on graph B, what is on y-axis, in graph C, what is on y-axis. Can you guess?
Active efficiency, sir.
Tracking efficiency is in which graph? A, B or C? In graph A, we have what thing on y-axis? Any guesses?
Rolling resistance, sir.
Yes. Rolling efficiency. This is rolling resistance.
Sure. In B, it is net active efficiency, sir. Net active coefficient, sir.
Net traction coefficient. Correct. Net traction
In
coefficient.
in C, it is tractive efficiency, sir.
Okay,
Option
can
C,
you
sir.
tell? And that is correct. You are 100% correct. Means this is rolling resistance, this is NTC, rolling resistance, net traction coefficient, traction efficiency. Means option C is correct. So answer is C. So can you tell that in rolling resistance, this the upper curve is for what soil and the lower curve is for what soil? Upper is for
Lower
soft.
one is for concrete, sir.
Yes, correct. And
Then
upper one is for
the upper one is
smooth
for
soil.
mud and slime, sir.
Okay, that you can see also, but can you explain that why in concrete it is at lower and why in mud it is at rolling distance is higher? Explain. You can you can tell that your concept is clear, I think. In mud soil, we get more sinkage. In concrete, there is no sinkage. Rolling resistance is mainly due to bulldozing or sinkage like that. So the tire will sink more in this muddy or slim soil or like loose soils. So we get more rolling resistance here. And in concrete, there is no sinkage, so the rolling resistance is independent of the wheel slip. Next is net traction coefficient, which is higher for concrete and lower for loose soil. The reason is also same. In week 1, what we discussed is that pull is nothing but thrust developed minus rolling resistance. In loose soil, this type of soil, rolling resistance is higher. So we get less pull developed with respect to slip. And when the rolling resistance is very low, net traction coefficient will be higher. That is the fundamental here. In tractive efficiency, why it increases then decreases? Can you explain? In zero slip condition, when slip is zero, we don't get any tractive efficiency because there is pure rolling. We no slip. We must need some slip to develop some tractive efficiency. If there will be pure rolling, there will be no shearing action takes place between the interaction of the tire and the soil. Then we will not get any pull. So we generally require pull only. If there is pure rolling, there is no slip, and we are getting no tractive efficiency. But as the slip increases, the more of the shearing action only takes place. That's why the tractive efficiency decreases. So we need to have some optimum slip range in which the tractive efficiency is highest. This is the curve of tractive efficiency versus slip. I will elaborate these things in next slides also. Coming to the next slide. This is the slide of net traction ratio versus tractive performance ratio. So you have to tell that this graph, this graph which is rising here denotes what? That this is B. This graph which is coming down, this curve which is coming down denotes what? It's denoted by C. And this blue line curve denotes what? This is A. So A you have to tell, B you have to tell, and C you have to tell. A, B, C are nothing but pull ratio, velocity ratio, and tractive efficiency. What is pull ratio? What is which curve is velocity ratio, and which one is tractive efficiency?
A will be tractive efficiency, sir.
Correct. B will be
Then B is a pull ratio, sir.
pull ratio. Okay.
And C is a velocity ratio, sir. Option D, sir.
Tractive efficiency, pull ratio, and velocity ratio. Tractive efficiency, pull ratio, and velocity ratio. Yes. So D is the correct answer. Do you know that tractive efficiency is nothing but product of pull ratio and velocity ratio? Pull ratio into velocity ratio. Pull ratio, can you explain what is pull ratio? You know, Sivanam, what is pull ratio? Pull ratio is pull developed by tractor by thrust developed by tire. Yeah, sorry, tire. Pull developed by wheel or and thrust developed by wheel. And what is velocity ratio? Velocity ratio is nothing but actual velocity or theoretical velocity. You know how we get this? What is the tractive efficiency formula? You know which formula?
Tight efficiency is drawbar power by axial power, sir.
Double power by axial power, right? So this double power is full developed into actual velocity and axial power is
Velocity. The axial power is
torque into
or
axial torque. So this pull into actual velocity by torque into omega is theoretical velocity by radius, and this T by R is nothing but the thrust developed by the wheel. So P into V A by thrust developed, or if you denote it with F, then P F into V. This P by F is called pull ratio. This V by VT is called velocity ratio. This pull ratio can also be denoted by mu by mu z, where mu is net traction of coefficient and g is gross traction coefficient. This way also we can denote, which is denoted here. NTR by GTR is nothing but this mu is NTR net traction ratio, and mu g is nothing but gross traction ratio. This is denoted here in this curve, and these two ratio are always less than 1. So the tractive efficiency will also be lower than this value. So the tractive efficiency is below these two curves. This is the justification of this curve. So you are correct. This is the correct answer, but explanation you are not correct. Okay, let us move to the next question. Penetration resistance measured using cone penetrometer has a unit of what? Any guess? Penetration resistance.
ask you, sir.
Sorry, I think you said right. What you said?
Ask you, sir.
Yes.
Pressure
Pascal.
unit, sir.
Yes, yes. It has the same unit as that of pressure. So can you define what is this penetration resistance? A cone index also. This is nothing but cone index.
It is resistance expressed by the layer of the soil or the soil portion against the pressure against the pressure or force we give to the soil, sir.
Means the force required to pull out this cone penetrometer inside the soil at some steady rate. Force required per unit area. So this force per unit area is kilonewton per meter square at some steady rate, and that steady rate is what, this is 30 mm per second. So how many types of cone penetrometer There are two types of cone penetrometer.
Yes, sir.
What what are they?
Static, static cone penetrometer is the impact type, sir.
Sorry,
Static cone penetrometer and impact type, sir.
impact type and
Static cone penetrometer.
what you are saying?
Static cone penetrometer, sir.
Static.
Yes, yes.
Okay, static. And the base area given by ASI. This is a standard base area which you can also remember. So the main thing is how to calculate the cone index of the soil. You have this cone penetrometer. This cone penetrometer, if you insert in the soil at some steady rate, and if you collect, if you are getting that what is the force required, you can get that from the sensor. Proving ring many here. If you a graph will come like this. If you will calculate the area of this curve. In the lecture in NPTEL, sir has mistakenly shown this side area. So you correct that this the area should be calculated of this part. This area you have to divide by the depth up to which you are going. So you will get the average cone index, and that cone index is the nothing but defines the that also classifies the type of soil in which you are doing the experiment. So on the basis of this cone index, you can mainly divide the soils in three types: soft soil, medium soil, and hard soil. So of what range cone index soil we say that this is soft soil. Can you make any guess?
For soft soil, the cone index will be 450 plus or minus 50, sir, in kilopascal.
Approx 450 range. So 450, remember you will have you will have your word. In medium soil,
1000 plus or minus 100.
in 1000, remember you will do the numerical order. Exactly question 20. And in hard soil you have 1800. So this was about cone index. So this question is very easy also, but tricky. Shear strength of soil is mainly governed by which two parameters? Shear strength of soil.
This is option. This is option D, sir.
D. No, this is not the
Yes, sir.
correct answer. I have written the expression. This is shear strength of the soil. What you are telling is not the shear strength of the soil. It's not the shear strength of the soil. It, that is the parameter, but when the tire interact with the soil, then these parameters will come. If there is no tire engagement, then how this can be the shear strength of the soil? This two will define.
This is option D, sir. Internal friction and the cohesion.
Yes, internal friction and cohesion. This C and phi are the two governing need-only shear strength parameters. If you multiply this two side with area, then you get the thrust developed by the soil, and this is AC plus W 10 phi. In this case, the thrust developed by the soil when the tire engages with the soil, in that case, A is also a parameter, C is also W, and phi. This is a function of four parameters, but shear strength of the soil is mainly governed by internal friction and cohesion. This is the correct answer. So, okay, next question. This also, if you have studied that NPTEL course, you will tell it simply. Theoretical question: which of the following is or are the laboratory tests or tests to measure the shear strength of the soil? Laboratory test, and what all tests comes under laboratory test?
Large shear, triaxial,
Direct shear, triaxial,
and van shear, sir.
wave
Van
shear.
shear, sir.
Okay, that is correct. So the answer is B, C, and D. Correct, you're correct. Okay, can you tell that which of the following expression is correct? Correct expression for torque required to cause shear failure of the soil.
Yes, sir.
Plus will not be there that you can cut from the options directly. The main confusing thing is 3 is here in the numerator and 2 is here in the numerator. So it will be 2 by 3 or 3 by 2. Which will be correct?
2 by 3, sir.
Okay. This is the correct answer. Mm, do you know its derivation, how it comes?
I don't know very definitely and clearly, sir.
Mainly formula is important, but you can know for your concept if this is angular ring, it has some depth.
Yes, sir.
If it has some radius r, for an incremental radius dr, and for theta, this will the arc length will be what? The length of this arc will be for rd theta. The length of arc will be rd theta, and the area of this incremental part is rd theta into dr. This is the area, and shear stress will be shear stress of tau F will be this area into the radius. R d theta into dr, and the moment arm will be moment arm of tau will be tau F into that area. So tau F into area. Tau F is okay. You do that. That is not necessary here. Mainly you have to do this integration. For r d theta, you have to do it for 0 to 2 pi, and for dr, you have to do it for r inner to r outer, and you will get this formula. You just remember this formula. You don't need to check correlation. So here in this curve, 3 graphs are shown. You have to tell that which is for hard soil and which is for loose soil and which is the intermediate one in this stress strain curve.
A is for highly compacted, sir. Option C, sir.
A is for highly compacted.
J is for highly compacted, sir.
Okay, correct.
And B is for loose condition, sir.
Yes,
And C is for the intermediate between A and B, sir.
yes, correct. So the answer is highly compacted loose condition. Also the correct answer is C. And you can also relate it with this is normal stress. If we draw it versus normal stress or sigma versus tau, then we get this type of curve, which we have studied many times. This is the angle of internal friction phi, and this is cohesion C.
Cohesion.
Uh, and in case you can also relate it with if this is W and this is the thrust developed by the soil, then this intercept is AC, and this is same phi. So coming to next question, which of the following is used to study both pressure sinkage test and shear stress shear displacement test? From what technique or test we study both pressure sinkage test and shear stress shear displacement test?
RMT technique, sir.
Yes, this is correct. So this is a Viva meter. So from which part is used to study pressure sinkage test, and which part is used to study shear displacement test? Can you identify? These are two plates, and if we if we give pressure with some cylinder or hydraulic cylinder, we will note the pressure required uh, do the sinkage. Then this side penetration plates are used to for pressure sinkage test, and this shear and annular ring which we derived earlier also. This is used to calculate the shear displacement calculation. This will be one of it. So in pressure sinkage, relationship of a terrain that is considered to be homogeneous within the depth of interest may be described by equation pkz to the power n. So in this expression of Baker's equation, what k is what? K is expressed as what? In this Baker's
It's a
equation,
constant that provides solid characteristics.
which option you tell? Which option? A, B, C, or D?
Yes, sir.
B.
Yes, sir. So Kc by D plus K pi.
Yes, okay, this is D. So D is the correct answer. And this is the graph showing pressure sinkage. If n is less than 1, this graph goes upward, and if n is less than 1, this goes downward, and for n is equal to 1, this is straight line. So the main thing there is how to calculate the exponent of sinkage and the cohesion modulus Kc and internal friction modulus Kp. Sinkage modulus of internal friction, sinkage modulus of cohesion, Kc, K5 and N. How you will calculate from that formula? The formula which we have is pressure is equal to Kz to the power N. If you take log to both sides, and if you suppose you are using two plates, then log P for one plate, log P1 is log K plus N log Z, and for second plate we have log P2 equal to log K plus M log Z. So you can make it analog of this with that mh plus c equation. This m is in the slope of the line, which is nothing but m. So m you can calculate from the slope of the curve, which you will get this alpha as suppose is your angle, then directly n will be tan alpha. And suppose two curves are not parallel, they are at some different angle. Suppose alpha 1 and alpha 2 you are getting, then alpha 1 plus alpha 2 by 2 will be your tan. This exponent of sinkage. For Kc and K5, if you have only two plates, then for you take at Z is equal to 1, sinkage is 1, and then this side will be 0, and this intercept is A1 and A2 for two plates. So A1 will be your K, that is case this P1 and this P1 K1 will all be same. If and in case of that Z is equal to 1, then A1 is Kc by B1 plus K5, and A2 will be Kc by B2 plus K5. If you do some mathematical calculation, you will get K5 as A2 minus A1, B1 B2 by B2 minus B1, and you will put this K5 in this equation. You will get Kc as A2 B2 minus A1 B1 by B2 minus B1. This question I will also give, and there you have to use this technique also only. Yes. I will come to that question. So in this question, you have to tell that A is which type of soil, B is which type of soil, and C is which type of soil. This is shear stress displacement relationship between the three soils.
So I didn't cover it yet, sir.
Sorry.
I didn't cover this part in the lecture till, sir.
Okay, okay. It's that earlier parts you had covered. That's why you were answering. Okay, you have good memory then. Then this is for shear stress displacement relationship. This is for loose soil. This is for organic terrain, and this is for compacted soil. Loose soil, loose or sandy or clay. This organic, and this is compact sand. So option one is correct. How this happens that I will explain that you can also get. So the thing here is that uh, you, uh, there are too many formulas written there for how for means what will be the shear stress developed by the soil. You don't have to remember that formula. You have to just know that curve. This curves only means how they are performing. For loose soil, this K is called, this K is nothing but shear modulus of deformation in all these cases. In this case, the tau max is here, means shear stress is developed, is taking peak at this point. So in case of loose soil, this K is you have to get one tangent at the starting of the slope and one tangent at the end of the slope where they meet the displacement. The displacement is called K or shear modulus of deformation. And in this organic terrain, when the tau max when the tau is maximum, this suppose this is tau max. So the displacement when we get the tau max is called Kw, and in case of this compact set where tau is taking the maximum value, this will be called Kw, and the part where this is getting constant is called residual modulus or residual displacement. You can also say this is generated by Kr. So for different soils, we have different shear stress formula that you can note. I have written that formula for you can also write it for loose soil. It is, if you want to note down, then
Yes,
you
sir.
can write for loose soil. It is tau equal to tau max into 1 minus e to the power minus j by k. This j is nothing but this displacement. This tau max is C plus sigma tan phi. This is the maximum shear stress which you can develop. And in any condition, tau max will be this only. So tau max is here also, tau max is here also, tau max is in here also. This tau max is only one formula, C plus sigma tan phi. And other parameters is for other conditions between here to here. This you have to apply at any j condition. You have j is the displacement, k will be, in this case k is the modulus of shear modulus, and k is this part, this value. And in this case we have another term Kw, and tau is divided by Varnica. Okay. Tau is denoted by tau equal to, that you can check from that NPTEL course. Tau is equal to tau max into j by Kw. Kw I have explained, into 1 minus e to the power minus j by k. And in this case, tau is equal to tau max is and into some function of suppose kr and kw. Kr is this value, and where it is getting constant, and kw is the value where tau max is getting maximum. So coming to next question, this you have to solve. This was there in the NPTEL also. A shear annulus with inner diameter of 50 centimeter is DI is 50 centimeter. Outer diameter DO is 80 centimeter. Torque required is given tau equal to 500 kg. You have to calculate the shear strength. Tau F, that's why. So formula you remember? Tau is equal to 2 pi tau F RO Q minus RI Q. You have to calculate this tau F. Do the calculation. What value you got? Sivaraman?
I got 4,955.038, sir. In terms of kilogram per meter square, sir.
Kilogram per meter square. Okay, correct. This was just formula, but this is the last question and means somewhat lengthier also. This you have solved means you have all the concept cleared of that pressure sinking beaver technique. So this is the values coming for two plates, plate 1 and plate 2. This side there we have sinkage and this side we have pressure. So you first tell me how will you proceed to find that n uh, that exponent of sinkage, then Kc, then K5. For n, what we do?
To require n, we should be plotting the graph for P versus Z, sir, which means which is we should be plotting a graph for pressure versus sinkage, sir.
Hmm. You have to you have to, if suppose this sinkage is Z and this pressure is P, you have to calculate log P and log Z. Do you have, you must be having calculator with yourself. We were getting some curves. If the curve is parallel, then that alpha is directly our exponent of sinkage n. And if the curves are not parallel, then we will take the average of two or two or more curves. If suppose this is alpha 1, this is alpha 2, then alpha 1 plus alpha 2 by 2 will be our exponent of sinkage. So first we need to find the log of this z, then log of. So I have done this. You don't need to plot that. This is sinkage, this is pressure, log P, and this is log Z. If you plot this, you will get this is pressure versus sinkage, and this is the curve of log P versus log Z. So for plate 1, the equation coming is 0.736x plus 2.79 4. And for plate 2, the equation coming is 0.344x plus 2.465. This is 5. So can you tell in this part what is our N and what is AC, what is K prime? Our actual equation was what? Log P1 is equal to log K plus N
N of log Z.
Z.
N value is the coefficient of X, sir.
So N value is N is the slope. In this equation, what is the slope of the line?
0.73.
And in this equation it is 0.344. So our slope is different. But we described earlier, if we have different slope line, then we will take the average of the two slope line. So one slope is there, 0.736, one slope is 0.344. So our N will be the average of these two, 0.736 plus 0.344 by 2. This will be our N. What it is coming?
0.54. 0.54, sir.
0.54. KC and K prime. KC was A2 minus A1 B1 B2 by B2 minus B1. B is our plates dimension, plate 1 and plate 2's dimension, and A2 is A1. A2 and A1 are the intercepts. This is for plate 1, then this is A1. If this is for plate 2, then this is A2. This one is only A2 because in this condition we are taking Z as 1, means log this log A as for Z is equal to 1, log Z will be 0, so this line will come. So we are taking this line only. So our A1 value is this intercept 0.294. A1 is equal to 2.794 and A2 is equal to 2.465. This is A1 and A2 and plates dimension is B1 and B2. So plates dimension is 700 into 110. So which of the following is which in 700 and 110, which one is B? This dimension, this is 800 into 100. Suppose this is 800, this is 100. This is rectangular plate of dimension of length 800 and width 100. So B is what? B is always the smaller dimension between these two. So this is 110 mm for B1 and for B2 it is 100 mm. B1 is 110 and B2 is 100. You put this A1, A2, B1, B2 in this case, you will get the case. Dimension is uh, expression. You are putting that value, Shivram. Have you done this?
Working it out, sir.
Okay, you do that. Till then, I'll talk with this. Vernika, are you there? Hello, Vernika. Vernika, are you there? Vernika, am I audible? What will you got? Can you unmute yourself, Vernika? I will give you some objective questions to solve. Questions are very simple only. That will help you. Vernika, you just tell me the answer. I'm not going to solve these questions. You have to just tell the answers. You can write in the chat box also. What will be the answer of this question? In case of toad will, which of the following expression is valid? Sivaraman, when you are done with that case in K5, you just tell that value. That was the last question. Hmm. Vernika, which of the following is correct? In case of toad will, toad force is equal to what? If you don't know, you can tell that. Okay, what was KC and K5? Sivaraman.
KC value is 361.9, sir.
What? 69.
Uh, KC value is 351.9, sir.
350.9. And K5 is
And K5 is 6.04, sir.
6.04. Okay. This was the last question. So Uh, Sivaram, you tell me, miss, which type of questions you need more, or uh, I'm just miss asking a feedback. This type of questions are okay, or I have to increase the level of question, or what?
This is okay, sir.
Okay.
Sir,
Do you have any questions regarding those 2 weeks? Up to where you have covered in that NPTEL course?
I covered still 8 lectures, sir, and tutorial too, sir. I will
Tutorial
check
2.
in, sir.
Okay, okay. This
I
was
didn't
tutorial
cover
2.
the ninth lecture alone, sir.
Tutorial 2 is 10th, right? So this time you have enrolled in that course. You are giving that exam also.
I can't understand, sir. What's
This time you have enrolled in that course, or you are doing it just by yourself. Weekly assignments you are solving. You are getting that assignments. On what day you get that assignments?
um, sir? Actually, the last assignment and week two was assigned on Monday, sir. Then it should be completed before the coming 7th, sir. Week one and week two, the due date for the assignment is 7th, sir.
Okay, okay. So you have solved that assignment. Do you have any question?
In week two assignment, I have doubt on the lawsuit problem, sir.
Okay, you tell that problem. You can present that.
Yes, sir.
I'm not supposed to answer that, but I will give him.
Okay, sir.
You just tell that what was the problem.
Find the value of shear deformation modulus K,
Huh.
and that's the question, sir. And they gave the four options, sir.
Okay, this part you tell. This is here deformation order scale.
Okay, sir.
I think the question is framed from this part. I think in that question maybe tau max and j will be given. We have to find that k. Is it okay?
Okay, sir. Okay, sir.
Next question. J is
Then
displacement.
the last one,
Displacement will be. And
sir,
if
displacement is equal to the shear deformation modulus.
uh, and if tau max is not given and cohesion modulus and phi internal friction is given, then you can calculate tau max from there. C plus C naught tan phi. We put that is tau max. And if shear stress, suppose at this level shear stress is given, so this displacement will be given in the question, uh, and shear stress will be given. Tau max should be given. This is tau max. For that, you have to calculate k. You have to put all those things in this equation with k. What was the next question?
That's it, sir. That both are answered.
Okay.
Okay, sir.
Next week I will
I
be.
have another doubt, sir.
Okay.
Sir, the problem what we discussed now was the condition only we get for Z value is equals to 1, no, sir.
You are not clearly audible.
Sir, the problem lastly we discussed, no, sir.
Last week. Okay.
Yes, sir, that one is only okay if the Z value is equals to 1, sir.
Actually, this time only z is equal to 1. This time it's
Yes, sir.
problem.
Yes, sir. If there is a Z value of another value, uh, in the lecture, Sir said that we should be plotting a graph against K versus 1 by B, sir.
Okay. This K we are in this case we are getting we are limiting our derivation for z is equal to 1. If we do that for, then we are getting two plates of it. Means we will not get exact KC and K5. For that we need to have some more than two plates and more than three plates. If more number plates of plates will be there, we will get some more KC. Suppose some more K we are getting. Then we will make a line from that K value. The intercept will be the what was the formula? A is equal to Kc by B plus K5. So from earlier means values of plates, we got some K values, and this value will relate it with Ms plus C. See, this intercept is our K5 and X is our 1 by V for different V, means for different plates. Uh, this is for suppose plate 1, we will be having 1 by V1. For plate 2, we will be having 1 by V2. For third plate, we will be having 1 by V3. If we have 3 plates, and 3K we will get. The intercept will be our case KC. Suppose this is theta, then tan theta will be our KC. From here we can calculate KC and K5. This is for
And where will be taking the K value, sir? How we
sorry
will obtain the K value, sir?
K values you have to obtain from this calculation from z is equal to 1. This you will get some K value for one plate for as the problem which we have solved. We got some K value. This, you wait for another two plate, you will get some other K value. Then for other plate, you will get some K value. That is for only that K is limited. This the question which we solved here. This is for z is equal to 1 and we got some K value. For other plate, you will get some other K value. For other two plates, you will get some other K value.
So now you are displaying the graph now, sir. So for each of the lines, what are produced, we should be finding the slope, sir. Then that slope will be the K value of the each plate. Am I correct, sir?
Um, can you tell once again? Can you repeat, Sivanam?
Uh, Now previously we found that K value of that two plate now, sir.
Ah,
Like that, if there is a third plate or fourth plate until the n number of time, we should be calculating the K value of each plate, sir.
hmm.
So using that, keeping that as a K value, we should be proceeding furtherly. Am I right, sir?
Right.
Yes, sir. Thank you, sir.
Uh, okay, I will make one question on that for three plates. Then we will solve that in next week.
Yes, sir. Okay, sir.
Then it will be more clear, I think. For third plate, I will take some data from lab. Okay. Uh, do you have any more questions?
No, sir. That's it.
Okay. Then we can end our class here.
Yes.
Okay, bye.
Thank you, sir.